Okay, the integrals they're giving us are getting a little more complex, and so we're going to need some new tools. And the first integration trick that we show you essentially is the substitution process, where when you have a function of a function like this, we have 10x plus 7, which is a function by itself, and then it's inside an eighth power. That's a lot to manage all at once. And so substitution gives us a way to clear out some of this clutter and give ourselves an easier integral to work with. Now, if you were thinking maybe this is just 10x plus 7 to the eighth power, so you could write out 10x plus 7 8 times and expand it all, yes, that would work. It would take a long time. The probability of errors is extremely high. It's excruciatingly painful. So you get points for being brave enough to consider doing that, but let's not. We've got better techniques. And substitution is the one I would like to show you here. The idea is we're going to take this function inside here, the 10x plus 7, and replace it with just a single letter that will stand in for it, that will substitute for it. And the tradition is to use the letter U for the substitution. I don't know where they came up with that, honestly, but we're going to say U is 10x plus 7. Now, in this expression, we have U to the eighth power. We also have the derivative of x, and that's a bit of a problem. We need to substitute this out as well. We're trying to get rid of x completely, and having dx's hanging around is no good. Well, that's not too bad. What we do is we differentiate this thing that we just wrote. If u is 10x plus 7, if you differentiate this, you get the derivative of u is du. On the right, the derivative of 10x is 10 dx. The 7 just gets destroyed. And now we've got a way of handling the differential part. We can rewrite this integral now, and here's how it's going to look. We still have the integral. Where 10x plus 7 once was, I'm just going to write u instead. So we have u to the eighth. What do we put for dx? Well, we're not completely done here. Let's divide both sides of this by 10. Divide by 10, divide by 10. We get du divided by 10 equals dx, or if you prefer, 1/10 du equals dx. So any place there's a dx in this integral, we can write 1/10 du instead. Times 1/10 du. Okay, that's a little bit better. We can make it better yet if we scooch that 1/10 out in front here and say integral 1/10 u to the 8 du. Okay, this is now something the power rule can do for us. If you start with 1/10 u to the 8 and you integrate it, our procedure says the power should go up by 1, so now we get u to the 9th. Then we divide by the new power, so we get 1/10 times 1/9. It's going to be 1/90th in the end. U to the 9 plus c. And that's pretty much your antiderivative, except the original person who brought this to us was talking about x's, and they don't know what our u is. So at the end, if you do a substitution, it's good manners to revert it back to the original letters. This u that we've been using has been standing in for 10x plus 7, so now just put it back. 1/90th. Instead of u, we have 10x plus 7 to the 9th plus c. There we are.